let's talk about the conclusion. Probably, if you went back to the beginning of the lab, you probably, I can't be certain of this, but you may have suspected that as you increase the mass, the stretch also increased. And for a hypothesis, you might have said, if the mass increases, then the stretch increases also. Technically, if you wrote a straight line like that, you more technically should have said, if the mass increases, the stretch will increase at a steady rate. If you think that, that would be what Hooke's law would state for something that is perfectly elastic. So to look back at your conclusion now, you may have thought this was going to happen. And so what you would say is what your original hypothesis was. You would just restate that. And then you just make a statement. Do you think your data supports that or not? So if you have a graph similar to mine, like the red line, then your data partially supports it. This part supports it really well because it increased at a nice steady rate. But here, it's increasing at a slowing rate. It's not increasing quite as rapidly. So I would say, if you have a graph similar to mine, that your data at least partially supports your hypothesis, but maybe you weren't expecting the stretch to be so hard at the beginning and so hard at the end of the graph, so it didn't stretch as much at the two extremes. Here I'm trying to get you to do is say what your graph shows in words. If you have a graph like mine, you might say something like this. As the mass increases, the stretch increases at a steady rate in the middle of the graph, but at the two ends, it does not increase at a steady rate. Something like that. Then you need to back that up. So give a few data points to back up your statement. What I would typically do is I would say, for example, and then I might give 3 data points as examples of that spread out through your data. So I don't have numbers on mine, but so it might be, for example, when the mass was 25, 170, and 350, the amount of stretch was whatever that number is, whatever that number is, and whatever that number is. So if I put numbers in there, I'll just pretend. When the mass was 25, 170, and 350, the stretch was 0 centimeters, 20 centimeters, and 35 centimeters. And then here, I'm just getting you to say, hey, does the data support Hooke's law completely or not? And again, if you have a graph that's looking something like that, you might say that the middle part does support Hooke's law, but the two ends do not. And then, why does a rubber band not fully follow Hooke's law? I want you to make an inference or think about why that might be. Why is the stretch a little different at the beginning? And why would the stretch be a little different at the end? And I'll let you come up with some possible reason for that. You might think about what the particles are doing as the rubber band stretches in the rubber band itself. Hopefully that helps. Thank you.